No, I'm an audible, right? Good evening. Good evening. Good evening. Bro. Just let me know once. I'm audible, right? Slight breaking voice. Yeah, I will do that. Okay, cross check it one. Now. Yes, that will great. No. Then, how are you all? How's the weather there? Actually, you're raining. That's why I'm asking. Hi, Pua. Hi, Prakriti. Hi, Madhu. Ryan's here also. Yeah, I'm good. But rainy weather, no. Too much of cold. Yes, that was great. Then, how is going everything? Guys, if you want means, okay, try to contact me through your program fellows. Okay, if means in case if you want any DPPs, okay, daily practice problem, if you want means based on the concepts what I'm teaching, okay, try to contact me through your program fellow teachers who are there in our schools. No, okay, get me right. Okay. Still chemistry class is not at all. Done. Okay. Okay. Who is taking chemistry class now? Gopi sir or Shubham? You guys don't know the name of the sir? Okay. Complete. Okay, that's great. Sagar. You have to ask no. He's a teacher, he is teaching to you people. Okay, you have the name of the sir. Huh? Okay, it's cool. We'll start, guys. Okay, it's the right time to start the class. Oh, sorry, Leela. Karnataka. Is it really? I don't know, but it's streaming in YouTube also. No, that's why I'm using English also. Jai Kannada, I know. Okay, in between I will use Kannada also. Sure. Okay, guys, yesterday we started the capacitors. Correct now? Capacitors generally we known as a condenser in our rural areas. Correct now? Basically, we are using this capacitor to store the charges. And in an electronic appliances means we know that we are using that one in a fans and then mobile cameras, and in a farming agency means if we will come across the farming field means we'll use that for the motor pump starting के लिए use करते हैं. right now. There's a basic application and to know the capacitor where we are going to fix. Okay, but the thing which we are learning inside the chapter, it is completely different, right? So we'll take a quick recap what we discussed in the previous class. Okay, in a class we discussed capacitance kya hota hai. Actually, capacitor means I told you that storing a charge. Where we are storing the charge? On the some plate, means conducting plate के ऊपर star को store करते हैं. Correct ना? It's a conducting plate means on this conducting plate we are going to store the charges. इसके अंदर charge store होता है, right? इसका capacity define करने के लिए what I did, actually we derived a formula that is Q is equal to C into V. Here C stands for the capacitance, right? If I want to write the equation for capacitance, then it will become Q by V. Q by V. But here capacitance value, it is not depending upon either charge and voltage. Okay, it is an independent. Right now, I give a best example for this one, memory card. Karna, don't ever forget that one. Okay, if you remember memory card means it should be give the idea about the capacitance, right? And later on we discuss the SI unit for this capacitance even. Okay, SI unit क्या होता है? Charge per voltage means charge is coulomb, voltage के लिए volt. Okay, coulomb per volt is a SI unit for capacitance for a plate. Okay, and then we call this one as an Farad also. Okay, Farad. While writing Farad, try to write in a capital letter. While writing completely Farad, it is wrong. This is wrong representation. Okay, while writing Farad, we need to write like this. Okay, then and SI units, usually Farad means it's a very big quantity. I told you yesterday. That's why in our syllabus we will use millifarad, microfarad, nanofarad, picofarad, like that, right? And later on we discussed about the dimensional formula for Farad also even. Okay, dimensional formula will be m to the power of -1, L to the power of -2, T to the power of 4, A to the power of +2. We solved this one in our last class. Correct now? And if they are asking in the CGS unit, bro, guys, listen. In terms of CGS unit, they are asking for the SI unit means try to write this one. 1 Farad value will be equals to 9 into 10 to the power of 11 stat Farad. Okay, note on this equation, note on this term, 1 Farad value will be in CGS unit. Okay, 9 into 10 to the power of 11 stat Farad. Clear, right? Is there any doubt regarding about this concept? Up to now I explained. No, is there any doubt? Good evening, Ishwari. Hope it is clear, right, up to this point. Yes, good. Good. We'll move on to the next things which we discussed yesterday. Okay, next what we discussed, capacity of an isolated spherical conductor we discussed. Good evening, Yashaswini. Guys, may I know, is my screen is visible, right? I changed the screen. Just give me a confirmation. Last day also happened like that. That's why I'm asking. Is my screen is visible, right? Yes, that too great. Thank you. Okay, now third quantity, we discuss the capacitance of the isolated spherical conductor. Correct? Isolated means single. Okay, that is also spherical conductor. We got our answer. We know that potential will be KQ by R. From this equation, potential where we kept in the equation of capacity. Okay, capacitance we know that C is equal to Q by V. But spherical conductor के लिए potential already we discussed in a previous class. Whether it is a hollow conducting sphere or a shell. Okay, for that shell we have a potential V is equal to KQ by R. Now if I'm going to substitute this value in this equation, we will get here C is equal to 4 pi epsilon naught into R. Okay, this is a constant quantity, and then I told that capacitance of the spherical conductor, isolated spherical conductor, is depending upon the radius, that is R portion. Correct now? Done. And I also told you that now if we know that means our Earth also a sphere, right? Our Earth also is a sphere. Its radius will be 6,400 kilometers. right? Now if I'm going to calculate the capacitance of the earth, single, it's an isolated, right? In a space it is घूम रहा है space में, सिंगल है ना, इसलिए करेक्ट ना. द कैपेसिटेंस वैल्यू विल बी, अरे यार बैकग्राउंड म्यूजिक मेरे आ रहा है, सुन नहीं रहा हूं, जस्ट अ मिनट गाइस. Yes, so no, the capacitance value will be 1 over here 9 into 10 to the power of 9 into 6400 kilometer. If I'm going to multiply this one, means we will get here 711 microfarad. Okay, for a big earth, earth is very big. In that big earth only we will get only 711 microfarad. Means just imagine whatever the appliances we are using, no, in that appliances the energy will be stored less than this one, but we can utilize that energy more. It has some certain condition. Yes Rajat, kya karna hai yaar, yen madodu anta gottilla, it happens. Okay, this is a capacitance we discussed, right? Okay, done. Next also we discuss few more points. Construction of capacitor. Okay, how we constructed the capacitor? Capacitor, I told that it's a device that stores the electrical energy, also named as condenser, right? Here we took two plates, conducting plates. On this conducting plates, what we did, actually we charged these two conducting plates. Charging, you know, right? Charging by conduction, induction, something, what, in that method only. But here to charge the plate, we'll simply connect this one to the external battery. Okay, external battery के लिए connect करते हैं. On connecting one, on this place we'll get our charges. Okay, charge will be आता है, that's it. Or when the charge will become one by one, electric field lines will be start to develop between these two plates. If electric field lines are to start to develop, means potential will be developed across these two plates. Okay, if the potential is developed means completely, then we will say here capacitor get charged, that's it. Okay, and then symbol coming across to the symbol, yesterday I told you that, देखो इधर ये भी symbol है capacitor के लिए, ये भी symbol है, and then this is like symbol of capacitor only. These two are fixed capacitors. Okay, fixed value of capacitor, these two. Okay, these two are the fixed value of capacitors. But coming to the third one, this one is a variable capacitor, means capacitance can be changed. We can storing energy hai na, we can change the storing energy, not on the charge. Charge will be fixed hota hai capacitance ka, but storing energy can be variable here. That is represented by one arrow mark over that one. Okay, is there any doubt about these concepts which are explained in this slide? Let me know in a chat box. Rajat, Swati, Yashaswini, so many of you are here, right? Bharat, Devegowda, Ishwari, Gayan. Okay, Sneha, Swati, Trishna, Janvi, Mandya, Ram. Sir, it's maybe hungry. I don't know यार. उसका ओनर इधर ही है इसलिए. Yes, good. Okay, that's great, yeah. Okay, so now then capacitance. Capacitance means capacitor is defined as the magnitude of charge Q on the positive plate divided by the magnitude of the potential difference across. Okay, it is nothing but capacitance. Already I told you that. Now charging. Okay, charging क्या होता है? I told you that two metal plates we need to take here. The answer देखो इधर. Two metal plates we take here, and we connected these two metal plates with the external potential. Correct? Now when we connected this one here, means positive charges will be start to appear on the in this plate. Okay, कौन सा plate? Actually guys, please try to zoom your screen. Okay, I will explain. Zoom this portion. Okay, positive charge will be start to occurring here, and negative charges will be start to come over the surface of the second plate, BA. Okay, then in between these two there is a potential will be developed. Okay, कितना potential develop होता है guys? देखो इधर if it is DC battery, why no? It is 9 volt. 9 volt means across this two capacitor, up to 9 volt, these condenser or capacitors will be get charged. Means up to that point only current will be flowing in this. Once the potential across the capacitor plate will exactly equal to the potential of the battery. Okay, once these two potential will be become equal, there is no net flow of current will be takes place. Current बंद हो जाता है इधर. Clear ना? Current will be stopped. Do you know why? Good evening, Sanjana. Network problem from my end. Let me know, guys. Problem. Just a minute. Guys, check me now. Is my voice is correct right now? Is it okay? Yes. Good. सुनो. Yes, guys. देखो इधर capacitor है. Okay. This is battery. Okay. I connected the battery to the capacitor plates. इसका voltage था 9 volt. Okay. That time, capacitor is not at charge. When it is start to charge means current will be start to flow. At the time here capacitor will be start to charge. Okay, once like this charging, while charging potential will be start to increasing 0, 1 volt, 2 volt, 3 volt, 4 volt, 6 volt, like that. When it potential across this capacitor will become 9 volt, exactly 9 volt, the current will not flow in the circuit. Current will be breakdown here. Do you know why? I will give a best analogy to understand this one. Those who are not yet understand, no, I will give you now. देखो इधर, this is one tank. Okay, इसके अंदर पानी है. Here another one tank. Okay, इसके अंदर पानी नहीं है. Just think that this is a capacitor. This is battery. Okay, now what I will do, I will connect this battery to the capacitor. Okay, at the time the water will be start to flow from this tank to this tank. Correct. Up to what time it will be travel? दोनों का water level equal होता है ना. Up to that time water will be flow. Here water will flow. After then, is there any water will be flow from tank A to tank B? Let me know. No. In a similar way, guys, charges also will do the same thing here. Current, voltage also, potential, whatever the potential we are giving now here, 9 volt. This 9 volt will be come across the capacitor, means current which is flowing in the circuit will be बंद हो जाता है. Clear ना? New thing. Is it clear for everyone, right? I need response यार. आपका मदद बहुत होना है इधर. ನೀವೇ ನನ್ನ ಶಕ್ತಿಗಳೆಲ್ಲ. Okay, good. Okay, if you know that means I have one interesting question, guys. Okay, question क्या है देखो इधर. सुनो question. A light bulb, a capacitor and a battery are connected together as shown in the figure. Figure देखो एक बार. With switch, yes, initially it is open. Switch is actually initially it open. When the switch is closed, if I am going to close this switch, क्या कर रहा हूं मैंने इधर, इस switch को close कर रहा हूं मैंने. If I closed the switch, okay, which one of the following is true? Go through the equations first. Okay, options. The bulb will light up for an instant when capacitor start charging. The bulb light up when the capacitor is fully charged. The bulb will not light up at all. And fourth option, the bulb will light up and go off regular interval. Which is the correct option according to you people? Yes, good, good, good participation. Yes. Jansi, Swati, Yashaswini, Rajat, Yashaswini. Two to answer you people are giving. Okay. I will tell you. I will tell you. So, think करो और एक बार योचने मारी. Now only I explain the concept, right? Okay, when I turn off this switch, okay, when I turn off means or else I connected this switch, all right, at the time current will be start to flow. If current start to flow means these two are in series, means lights start to glow. Lights start to glow. In a simultaneously, the same amount of current is flowing here also. Correct now? During the same time when it is glowing, the capacitor will be get charged very fastly. Yesterday I told you that capacitor will be get charged very fastly and it will be get discharged also. Scenario I will explain when it will be discharged. Okay, it is actually DC source. DC source. At the time bulb will be get glowing here now. Man lo, this DC source is a 3 volt. Okay, the same amount of 3 volt will be appear on the capacitor means at the time current will be, now tell me, current will flow. After then, after fully charge of the capacitor, is current flow? No. If current will not flow means here, then light after glowing, this light will be off. Correct now? Sorry. After then, light will be off ho jata hai. Means now cross check your answer. Okay. First option dekho, the bulb will light up for an instant. When the capacitor start charging, right? Then correct answer is A. Clear now, guys? This is neat question. You can expect like this questions only. Good. Okay. If it is understood means we'll go to the next concept, today's concept. Okay, capacitance of the parallel capacitor. Guys, we know that one single plate if I'm going to take means, okay, इसका capacity भगवान already print करके देता है हमको. Okay, कितना होता है उसका capacity? Q by V. That's it. Okay, it is actually not depending upon the Q also, not depending on the V also, right? Actually, this is depending upon the dimensions. Yesterday I told you. Now we are discussing about the capacitance of the parallel plate capacitor. Parallel plate capacitors. देखो क्या होता है parallel plates. Parallel plate capacitor is an arrangement of two parallel conducting plates of equal area separated by a air medium, air or any another insulating medium. Either they may be keep in a air or some other medium. I will tell you in our coming classes onwards. We are going to discuss that one also. Dielectric medium will become. Okay, dielectric. Dielectric का मतलब होता है non-conducting medium. Okay, we're going to place that one. When non-conducting medium, we are going to place that one inside the capacitor means what will be the capacitance? We'll discuss that one in a later class. Now, देखो इधर, for making that one, we are using mica, glass, wood, ceramics, etc. Dielectric mediums, these are. Okay, now we'll go through the arrangement of the parallel plate capacitor. कैसे होता है? देखो इधर. This is a parallel plate. Correct now? This is a parallel plate which has already positively charges, and another plates which are having a negative charge density sigma. Correct now? These two are actually, guys, separated by a small distance. This distance is there? No, it should be very small. Comparison you might be asked. Okay, comparison will be, it should be very small comparatively their area or length or breadth. We can say directly area. Okay, if I'm going to take the area compared to that area value, this distance should be very much small. Clear now? Then only we can say it is a capacitor, and it will stores the non-conducting substance like dipolars. Dipolars. Okay, what I'm saying, actually I forgot. Okay. Distance, yeah. This distance should be very small comparatively their dimensions. Okay, comparatively their dimension, this distance should be very small. Then only we can say it is an capacitor and it will stores the energy properly. Okay, we'll discuss the capacitance now. Capacitance, if I want to find out, means we need capacitance C is equal to Q by V. करेक्ट ना गाइस? Q by V फाइंड आउट करने के लिए देखो इधर क्या क्या करता हूं मैंने. पहले I need to know, guys, इधर देखो, here I took one equation, V is equal to E into D. Don't be get confused here with this one. What is this one? No, we know the relation between electric field intensity and as well as the potential, that is E is equals to minus dV by dr. Minus dV by dr. I will tell you how this kahani came. Okay, simple sa way I will tell you. Okay, देखो इधर, this is dV. If I'm take to dr left hand side, means it will become E into dr is equals to minus dV. इधर फिगर के तरफ आना है. अब फिगर के तरफ आ जा. In this direction electric field is there, right? We know that this is a positive charge. This is a positive charge. Guys, potential difference define करने के वक्त हम मैंने बोल दिया था, potential difference means potential means bringing a unit positive charge from infinity to that field. Means either positive charge here means we bring this positive charge from where, from here to here, right? Electric field के opposite लेके आता हूं हम, correct ना? That time, guys, that time I'm telling you, if I bring this one from here to here, means it travel a distance d. It travel a distance d, but electric fields are in this direction. Okay, this is the direction of electric field, in this direction, right? We are bringing that one in opposite direction. Plus charge को opposite direction bring लेके आ रहा है, correct ना? Then we need to integrate this one, integrate both the side, correct ना? This is E dot dr. Now E dr cos theta is equals to minus dV. इधर देखो cos theta कितना होता है ये दोनों के बीच में एंगल 180 ना. cos 180 का वैल्यू कितना होता है? cos 180. May I know in a chat box what is the value of cos 180? Yes bro, right. Good. Yes Rajat. Okay, cos 180 का वैल्यू होता है, किधर हो, कहाँ हो गया? हाँ, -1. If I put -1 here, means then integration, same integration है. Okay, E dr into -1 is equals to minus dV integration. Integration of dV, it will become V, total voltage. इधर देखो, E dot dr is there. E is the constant one. Take it outside. If you're going to integrate the dr, means dr integration will be d only, right? This distance only we are bringing, no, right? That's why integration of dr, what I will write, guys, I will write this one as an d. Here -1 is there, -1. This -1, this minus cancel. Then what we get? E into d. Right now, this is actually derivation, guys. So no, I say derivation करते हैं ना, imagination करके what is the function is going on there. These are the actually questions for the competitive exams. These are the questions for the competitive exams. Yes, Rajat, good bro, good Jansi. Clear, right? What I'm saying? Simple सा होता है, concept समझना है, उसका treatment करना है इधर. That's it. After you become a doctor, no, you will treat patients like this only. What is the problem? You need to analyze. Later on, you need to give the perfect treatment for them. Here also same thing. Before that, you are doing doctoring here. Good. Shall we move on? And meanwhile, if you people are feeling like I'm going fast, means let me know in a chat box directly. Good. Sorry. will it be tricky as physics? Yeah, bro. Okay, so we'll continue. Okay, here V is equal to E into D we got, and V value here in the place of E we substituted sigma by epsilon naught. Do you know why I substitute sigma by epsilon naught? In a last chapter, last concept मैंने बोला था, एक second region में sigma का value क्या होता है? Actually for a single sheet, electric field intensity होता है, in a corner I'm writing guys, sigma by 2 epsilon naught. But in this region, in this second region means middle region में sigma दोनों direction means positive plate के वजह से electric field इधर था, negative field के वजह से electric field इधर था. Means we need to add E1 for the first plate and E2 for the second plate also, sigma by 2 epsilon naught. And adding these two value, what we will get? 1 by 2 plus 1 by 2. It will be 1 only. It is nothing but 1 only. Correct now what I'm writing? That's why your net electric field intensity will be sigma by epsilon naught hota hai. That is the thing I'm going to substituting here. Right? Sigma by epsilon naught. Exactly right. Correct now. Remaining thing will be D as itself. Right. Next thing. Now, देखो इधर V value will be equals to sigma. We know guys, sigma क्या होता है? Sigma is equal to charge by area. Charge by area. Exactly right. Now I replace the sigma by charge by area. We got voltage value. Voltage value. Capacitance find out करने के लिए हमको क्या चाहिए? इसके वजह से Q है, and then V. V required. We find out the V value. And देखो क्या हो गया now? C is equal to Q by V. Now in the place of V, substitute this value QD by A epsilon naught. And substituting this one, we will get, I will substitute here and I will give the answer also. It is not good war writing. Okay, look at here. C is equal to Q by, in the place of V, we can write QA upon, one second. QD, right? Okay. QD divided by A epsilon naught. This Q cancel. This denominator of the denominator comes to numerator. Hence it will be A epsilon naught divided by D ho gaya. This is the capacitance of the parallel plate capacitor. Exactly right. Guys, understood right? How I calculated? Is it understood? I explained everything, whatever required for this derivation, how I took that. Now I bring a concept of previous class also. Right, good. Meanwhile, if you had any doubt means, please let me know. Okay, cool. देखो इधर next क्या होता है? Same thing. I will quickly summarize. It's a sigma charge density on a plate A. This is charge density of a plate B. ये दोनों का बीच में distance D था. ये दोनों का बीच में electric field intensity कितना होता है? Sigma by epsilon naught होता है. Don't forget this one. Okay. ये दोनों का बीच में potential find out किया हम. Potential का value आ गया QD divided by A epsilon naught. Okay. This value we substituted in C is equal to Q by V. Okay. After substitution, we got a capacitance value A epsilon naught divided by D. This is for a parallel plate capacitor. Right? Okay, cool. If in case they are asking about the medium पूछने से आपको इसको replace करना पड़ता है. This is permittivity in a free space. Means relative permittivity value will become epsilon naught in medium divided by in a free space we need to calculate. Correct now? Here we want to write the epsilon medium means we need to multiply this one to relative permittivity. Then it will be epsilon naught value will be equals to epsilon. Okay, this value we need to replace here. Then we will get this equation. Okay, cool. Koi problem nahi. Okay, they never ask this question. It's sure. Okay, just you have to remember this thing. That's it. And then देखो इधर capacitance of a parallel plate capacitor is directly proportional to area of the plates. Guys सुनो. Okay, इधर capacitance will be A epsilon naught divided by dA. If I'm going to increase the area, charge density will be increases. If charge density increases means capacitance will be increases. Correct now? Storage capacity will be increases. That's why capacitance of the parallel plate capacitor we can increase by increasing the area. Okay, what if I'm going to increase the distance, a distance the 4 millimeter, if I'm going to increase this one for a 40 centimeter, okay, then what happened? Capacitance dekho, it is reciprocal here. Correct now? If you increase the D, then capacitance will become decreases. Okay, capacitance will become decreases. Yes, Manthan. Actually, epsilon naught value, if I'm going to take free space, actually I won't talk that one here. I want to introduce one here, dielectric medium. Okay, after then only I will talk with the term epsilon naught. Okay, dielectric medium insert करने के बाद बात करता हूँ इसके बारे में. Okay, connect होता है. That's why connect आगते ತುಂಬಾ ಚೆನ್ನಾಗಿ connect ಆಗುತ್ತೆ. If I'm explaining that one after introducing the dielectric medium. Yes, dielectric means non-conducting. It's an insulator. It's an insulator. देखो एक क्वेश्चन है, क्वेश्चन करना है आप. सुनो, I will explain first. Try it. I will give her 2 minutes, and later on I will solve this one. Okay. Capacity of a parallel plate condenser is 10 microfarad. Means they given capacitance 10 microfarad. When the distance between its plates is 8 centimeter. Okay, distance is 8 centimeter. At the time its capacitance will be 10 microfarad. If the distance between a plates is reduced to 4 centimeter, this is first capacitor, मान लो. Okay, now I'm preparing the दूसरा capacitor. Second distance is 4 centimeter. Okay, if I'm going to reduce the distance between a two capacitor plates is 4 centimeter, then its new capacitance, what will be its new capacitance? They're asking. Okay, double agata. Okay, I got answers. Good. Try it through the equations. Okay, capacitance के लिए equations क्या है? A epsilon naught divided by D. Try it from this equation only. I'm getting answers, but meanwhile I will give 1 minute of time because here so many of the students are trying. No, if I suddenly start to try solving means they will get yes, right guys, what you are saying are giving the answer, it's right, but let them try. I would like to give opportunity for everyone. But guys, don't ask this one. Similar to CPMT. What is this? I don't know full form of this one. Sorry for this one. Outstanding. Okay, Rajat. Okay, got it. Yes, guys. So many of all of you are given an answer maybe. Okay, capacitance find out करने ये equation है ना, but इधर हमारा काम है distance के ऊपर. Means here capacity is inversely proportional to distance. This is the equation we need to take. Correct ना? First capacitance क्या है? C1 is proportional to 1 by D1. I will take. I want to find out the C2 value. Means this is C1, this is C2, this is D1, this is D2. If I'm going to take like this means, okay, I will take ratios of these two. Means C2 will become again 1 by D2. It will comes to numerator D2 here. Means I want to find out C2 means now I will write C2 by C1 is equal to D1 by D2 are proportional. Right now C2 value will proportional to D1 का value कितना था 8 centimeter, D2 का value कितना है अब 4 centimeter into C1. I will multiply to right hand side, then it will be 10 microfarad. Centimeter से centimeter मर गया, 4 ones are 4 twos are. Then second capacitance will become 2 into 10. It will be 20 microfarad. Got it right? Awesome, awesome. Okay, everybody given a correct answer with the same Josh, guys. In the same Josh, Ade Kushili, try to solve this problem also. Add another problem. And meanwhile, if you had any doubt in a previous problem, means no need to hesitate. Directly ask the question in a chat box. This is the second question. I will explain the question first. What is the area of the plates of 3 farad parallel plate capacitor? Of 3 farad parallel plate capacitor. Okay, I know. Mera students hai. Okay, Shashank, take a screenshot. Take a screenshot. Done. Okay, we'll move on. Okay, देखो इधर एक पैरेलल प्लेट कैपेसिटर है, उसका कैपेसिटेंस है 3 फैरेड. Okay, and if it is separation, okay, if the separation between our plates is 5 millimeter, okay, then what is the area of the plate they're asking. देखो इधर, you need to calculate the area of the plate, but capacitance they given 3 farad and separation distance D also they given 5 millimeter, means it is nothing but 5 into 10 to the power of minus 3 meter, and then you need to calculate the area. That's it, right? हाँ, area calculate करना है. कैसे करते हैं, करो. Hey, outstanding. Okay, good. Capacitance will be A epsilon naught divided by D, and epsilon value you need to keep here. Correct now? Epsilon value hota hai 8.85 into 10 to the power of minus 12, right? Yes, 12. I got 2 answers. Good Manthan. Rajat, calculate on the paper, yaar. Why you are calculating in a chat box? Oh my god, we'll calculate this one. देखो, area calculate करना है, इसलिए D take to left hand side. Then it will be CD divided by epsilon naught is equal to area. Sir, ಮೊದಲೇ answer. हाँ, ಗೊತ್ತಾಯ್ತು bro, ಗೊತ್ತಾಯ್ತು. Okay, good. CD by epsilon naught into area. Capacitance they already given 3 farad. Guys, देखो, we utilize here 3 farad. Don't ask me that. Sir, you told me that in our initial classes only we are not using farad. Why you are using? Okay, don't ask me like that. Somewhere in our problems we will use, but in appliances we are not. We can't able to use that much of farad. Right now, कोई problem नहीं. Into D देखो, D कितना है? What is the D value? 5 millimeter. 5 into 10 to the power of minus 3 and divided by 8.85 into 10 to the power of minus 12 is equal to E. Okay, next step देखो, 3 into 5 into 10 to the power of minus 3. I will write this 8.85 for my calculation, guys. 9 into 10 to the power of minus 12, approximately 9. Okay, 3 ones are 3 threes are. Okay, remaining portion I will write in the right side here. देखो इधर, remaining thing will be here. Okay, 5 by 3 into 10 to the power of minus 3. 10 to the power of minus 12 comes to numerator, means 10 to the power of plus 12 is equals to area. Correct now? And then 5 by 3 means it is nothing but 3 ones are 0.36, right? Into 10 to the power of minus 3 and then plus 12 means it will be plus 9. Area means meter square. Guys, देखो इधर. So no, I will tell you one interesting point here. Why I took 3 farad also, why this example also I will tell you. 1.6 into 10 to the power of 9 means after 1.6 you need to keep 10 zeros. 10 zeros. Correct what I'm saying? That much square area of plate, if you are going to take, means only you will get 3 farad. Only you will get 3 farad of capacitance. Now tell me, is it really required to store 3 farad of capacitor? Is it possible to place the capacitors like that in that big area? That's why this one farad we are not taking for the appliances. Clear enough? Good. Okay. If it is clear, means let me know. We'll move on to the next concept. Okay, that too great. That too great. Okay, capacitance of the spherical plate capacitors are there. Guys, I will do this one in a next class. Okay, spherical capacitors and as well as the cylindrical capacitors. But I will bring you in a new another one topic, series combination of capacitors today. Okay, series and as well as the parallel combination. Then Prabhu would have been better than mixer. What happened to you, bro? Cool. Okay, let us go through the series combination of a capacitor. That is also even parallel plate capacitor. Okay, I will tell you that how the series combination will be takes place. Dekho, this is one capacitor, guys. Okay, this is one capacitor. It has a 2 terminals. This is the first terminal. This is the second terminal. Correct now? Now, and one more point, this capacitor doesn't have any positive and negative terminals. Okay, doesn't have any particular positive and as well as the negative terminals. उसको ध्यान में रखना है. Okay, if you देखो इधर, if I'm going to connect this one to battery here, means it will be get positively charged now. Okay, if I'm going to reverse this battery reverse किया, now it is positive, it is negative. That time it will get positive now. ऐसे change हो सकता है. Correct now? That's why it doesn't have any particular polarity. Clear enough? Next, this is the first capacitor. I'm going to connect the second capacitor like this. Combination देखो कैसा है, right? And I'm going to connect with the third capacitor like this. Like this connection, end-to-end connection of a capacitor plates, we call as an series combination of a capacitor. What we will call? We'll call this one as a series combination of a capacitor. Now, देखो simple है. If I'm going to connect this one for any external battery, okay, this is a battery which has a potential V. What will be happen at the time? Here current start to flow. Current is flowing is nothing but moving of charges. Moving of charges. Charge क्या होता है? इसके ऊपर पॉजिटिव चार्जेस आता है, बट ऑपोजिट प्लेट के ऊपर नेगेटिव चार्ज आता है. ऑपोजिट के प्लेट के पास क्या आता है गाइस? देखो थोड़ा जूम करके देखो, ऑपोजिट के प्लेट के पास नेगेटिव चार्ज आता है. इन दिस सेम लाइन आई एम कनेक्टेड, नो दैट्स व्हाई इन सेकंड प्लेट के फर्स्ट प्लेट, सेकंड कैपेसिटर के फर्स्ट प्लेट के ऊपर भी अगेन पॉजिटिव चार्ज विल कम एंड सेकंड प्लेट के ऊपर नेगेटिव चार्ज. If one positive charge will be come here, means one negative charge will be automatically induced on the second plate. And then third capacitor also similarly, charge will be occupied here positive, another one will be negative here. Clear now? When we connected the capacitor in series like this. At the time, guys, at these two ends, if I'm going to take these two ends, means potential will be V. But here देखो क्या होता है, after when the charge will be distributed equally, here charge will be distributed very equally, but potential difference will not distributed equally. Here potential across the C1 and C2 and C3 will be different. C1, C2, C3 potential will be across them will be different. It is depending upon the capacitor how much we fixed here. Okay, across the C1 will be V1, across the C2 will be V2. Try to zoom this figure, guys. I'm explaining the figure. Try to zoom your screen. And across the capacitance, the potential will be V3. If I want to find out this total potential means, I want to find out the total potential means what I want to do. ಏನ್ ಮಾಡ್ಬೇಕು ನಾನು ಇವಾಗ? Yes, yes, bro. Yes, right. Yes. Total potential if I want means, अरे यार, Rajat integration ಏನಕ್ಕೆ? Simple. Integration simple form will be, simple formation of integration will be, that's it, addition. We need to add all the voltages. देखो इधर V1 plus V2 plus V3 ऐड करना है. ओके, V1 का किधर से मिलता है हमको ऐड करने के लिए? कौन देता है? डोंट आस्क मी लाइक दैट. हाँ, सेम ब्रो, अदे अदे. Okay, here C is equal to Q by V is there. If I want to find out the V means, take it this side, then it will become V is equal to Q by C. Right now, this is a general format. Okay, but V value can be written as Q by C. Right. For the capacitor 1 के लिए क्या लिख सकते हैं? Potential. We can write that one. V1 is equal to Q by C1. But don't write Q1 because when they are connected in series, charge will be same on all the capacitor. इसके ऊपर 2 charges है means इसके ऊपर भी 2, इसके ऊपर भी 2 भी होता है. ध्यान से सुनो. And then on the third, second will be Q by C2. On the third capacitor, it will be Q by C3. Now we need to substitute all V1, V2, V3 value in this equation. If I substitute that one here means, देखो, V means Q by C, V1 means Q by C1, Q by C2 plus Q by C3. If I'm going to take here Q as an common, okay, Q will be get cancelled. Remaining, what we will get? Only I will get here 1 by C1 is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Means if I'm going to keep 3 condensers or capacitors in series, instead of these 3 capacitor, I can manage this circuit with a single capacitor. That is given by, that equation is given by 1 by C1 is equal to 1 by C1 plus 1 by C2 plus 1 by C3. That equivalent capacitance. Are you getting my point, right? Yes, sir. I about to tell that only now. But you people guys know that, right? In last means 10th standard, you studied that one. Resistance are in parallel. Okay, there in a parallel, capacitor will be in series. Vice versa. Okay, resistor and capacitor के लिए vice versa means उल्टा होता है. Here equivalent capacitance, if I want to find out in a series means, we will take a reciprocal of sum of all the capacitors. Clear? Is this concept is clear, right? I need quick response, guys. ಯಾರ್ಯಾರು ಇದ್ದೀರಾ ಎಲ್ಲ quick response ಕೊಡಿ chat box ಅಲ್ಲಿ. I hope nobody is sleeping. Good, Rajat. Good, Ashwini. Good, Swati. Yes, good. One more Swati. Impana, right? Thank God. C is the equivalent capacitance or effective capacitance of, or net capacitance or total capacitance. Guys, these all are same only. In the question, they might be asked like this only. Find the equivalent capacitance, they might be asked. Find the effective capacitance, or they might be asked capacitance or net capacitance or total capacitance. Like that, they might be asked. Okay, koi problem nahi. What are the things we find out here? Dekho, in a simple way, I will explain you. I connected the capacitors in series. When I connected this one in a series, all the capacitor will be charged with the same charges. Okay, but the potential difference across the each capacitor will be different. If I want to find out the capacitance means, we'll take what we took, potential. Correct? Now equivalent potential will be V1 plus V2 plus V3. From this equation, we solve the equivalent capacitance of these 3 capacitor as an reciprocal of the each capacitance of sum. Okay, C1 1 by C1 plus 1 by C2 plus 1 by C3, like this. If I'm going to take only 2 means, how it will become? Dekho, 1 by C is equal to 1 by C1 plus 1 by C2. Okay, That time no need to calculate the क्या है denominator LCM लेना कुछ भी नहीं है. Simple से I will tell you 1 by C is equal to, if I take LCM means C1 C2, ऊपर क्या होता है C2 plus C1. This is reciprocal of 1 by C1. If I want equivalent capacitance means C equivalent will become now C1 C2 divided by C1 plus C2. Okay, in two capacitor system, try to calculate like this only. This is short trick. Okay, this is the short trick. How to remember? In a simple numerator में multiplication, in numerator multiplication, denominator addition. Clear now? Let me know, is it clear? Yes, good. We'll move across the second combination, that is a parallel combination. We'll finish that one today. Okay, tomorrow we'll solve the problems, and spherical conductor tomorrow I will bring. Okay, the reciprocal of the effective capacitance मैंने बोल दिया. Good. One more point guys, one more point I want to tell you here. Guys, मान लो this first capacitor है ना, just imagine like that. First capacitance capacitor will be 6 microfarad, मान लो 2 microfarad. Second capacitor capacitance will be 2 microfarad. Third one will be 2 microfarad. Okay, if I'm going to, sir, first slide 1 second. अभी I will do. देखो इधर 2 microfarads are there. Okay, if I combine this all the capacitors means total capacitance आता ना, C equivalent capacitance will be less than we can write, yeah, less than 2 microfarad we will get when they are means they are connected in series. Okay, अभी take the screenshot. Take the screenshot. अरे यार, yeah, I will tell you, Rajat. I will tell you. All right. सुनो. I will explain you in a quick way. किधर ही explain करता हूँ मैंने, देखो. Okay, मान लो these are the 2 capacitors I took. Okay, I connected with a battery. Okay, first one capacitor, so the series connection. This is 2 microfarad. Second one will be 2 microfarad. Okay, if I calculate the C equivalent value, I told you that multiplication by addition. C1 C2 divided by C1 plus C2. C1 कितना है 2 into C2 कितना है 2 divided by C1 plus C2 means it is nothing but 2 plus 2 4. Okay, ऊपर भी 4 होता है, नीचे भी 4 होता है. Then it will be 1 microfarad. Look at here, Rajat. Means whenever we are going to connecting the capacitors in series, okay, equivalent capacitance always we will obtain less than the actual value of the capacitance. Actual value 2 microfarad था, but equivalent microfarad कितना आ गया 1 microfarad आ गया. Right, this is the concept which I would like to tell. Clear now? Give me a quick response. Time is too less, I have to finish. Okay. I have to take one more क्या है यार इधर, parallel combination किधर है, इधर ही. Okay guys, सुनो इधर. Next concept है parallel combination of capacitor. In parallel combination of capacitor, देखो guys, capacitor I will take 3 capacitors as usually, 3 capacitors, but we need to connect the capacitor in this pattern. Okay, all the one side of a capacitor should be connected to one positive potential of the battery, and then all the negative terminals should be connected to the another side of the battery. Hence, one side of all the capacitors will be get positively charged like this. Right? देख रहा है ना आप इधर, देखो ध्यान से. When we connected positive potential means one side they will get positively potential, other side will be get negatively charge. Correct now, but here instantly, at the same time, instantly current start to flow here, I amount. But when it is come to this junction, no, this I amount will not go directly. Either thoda de ke jata hai. Means I will call this one as an I1. When it is come to here, I2. When it is comes to here, I3. Means kya ho raha hai idhar? Current divide ho raha hai. Current is dividing means it is none other than charge is dividing. करेक्ट ना, चार्ज डिवाइड हो रहा है. बट देखो इधर पोटेंशियल ये दोनों के बीच में कितना था, V था. ये दोनों के बीच में भी कितना होता है, V होता है. बट इन दिस इक्वेशन गाइस पोटेंशियल विल बी सेम. यस राइट, ओके. पोटेंशियल विल बी सेम इन पैरेलल कॉम्बिनेशन. देखो इधर एक्सप्लेन कर रहा है. फर्स्ट पॉइंट इज दैट पोटेंशियल इज सेम अक्रॉस द कैपेसिटर but charges are distributed directly proportional to the capacitors. Based on the capacitance, the charge will be distributed. Okay, then now we need to calculate the equivalent capacitance. Correct now, equivalent capacitance find out करने के लिए either we have to take the Q values. Okay, Q is dividing, no, that's why we are taking here Q. But Q calculate करने के लिए again we have to go through the capacitance equation, that is C is equal to Q by V. If I want Q means what we will do, Q is equal to V को इधर multiply करो, C into V. Correct now, like that for all the capacitors we need to write. If I write like that, no, then देखो Q1 value will come out to be C1V. V is same, that's why I'm writing V itself. Next Q2 is equal to C2V. Q3 is equal to C3V. Correct now, and as we know Q value will be equals to CV. Now if I'm going to substitute all the equations here, means first Q is equal to CV, second one will be C1V, C2V, C3V. In this right hand term I will take V as an common. Okay, common लेने से क्या होता है, we can cancel this V. Then what we will get, finally we will get the answer C value as an C1 plus C2 plus C3. देखो इधर actually we connected the capacitors in parallel, right? In parallel combination we got direct summation of all the capacitors. Summation of all the capacitors, n number of capacitor you connected. Okay, it will give the values like this, C1 plus C2 plus C3 plus C4 up to Cn. Now tell me, yes Yashaswini. Okay, now tell me, this is an equivalent capacitance. Okay, is that equivalent capacitance in the parallel combination, will it give maximum amount of capacitance or minimum, means compared to each capacitance which we are connecting in a circuit. In a circuit I connected 2 microfarad. 2 microfarad capacitance I connected. Correct now, will it be less than the 2 microfarad or more than that one? यशस्विनी चेक करो एक बार. Yes, देखो if I'm substituting here means C value will be 2 microfarad plus 2 microfarad plus 2 microfarad, right? Total it will be 6 microfarad. Correct now? Yes Rajat, right. Maximum value we will get, means if I want maximum value of current in a circuit means we need to connect the capacitors in parallel. Yesterday I told you an example in a daily life example. What is that? Fan rotate होने के लिए हमको maximum energy चाहिए. That energy is not given by the circuit current which is coming directly from into the home. That's why we are connecting a capacitor to the fan in parallel combination. क्या होता है? That time in parallel combination capacitor will be get charged very fastly and discharged also very fastly. That time current will be बहुत ज़्यादा होता है circuit में, right? That's why. Clear, right? आज का क्लास पसंद आ गया ना? I hope this class is better than yesterday. I given a good things. Okay guys, this is all about today's class. We'll connect in a tomorrow class. Until then, take care. Swastik, I'm from Tumkur. Okay, bye bye. but I'm teaching in Haveri, JNV Haveri right now. Okay, it's a good time with you all, guys. We'll see you in a tomorrow class. Until then, take care. Once again, bye-bye. Welcome.